Hôm nay mình sẽ hướng dẫn các bạn thiết kế mô hình MPC thích ứng với Simulink và hộp số công cụ điều khiển dự đoán mô hình cho hệ thống lái tự xe tự động.
As a state space system with an input of steering angle and outputs of lateral position and yaw. This time, its dynamics change with longitudinal velocity. Therefore, this now becomes an input to the plant block. We're going to connect a constant block for the longitudinal velocity, which will initially set to 50 meters per second and change to another value later. The other output is the states, which we'll use later. If you want to look under the blocks to see how they are built, you can download the Simulink model from the link in the video description. Next, we'll connect the adaptive MPC block that is in model predictive code. To implement the adaptive MPC, we can simply start with the MPC controller that we designed in the previous video for a longitudinal velocity of 50 meters per second. We already have the MPC controller object in our workspace. By typing it in the command window, we can see the design parameters such as prediction, control horizons, constraints, and weights. One thing to note is that the adaptive MPC block requires a discrete plant model. So we need to convert the continuous time state space model used by MPC1 to discrete time. There are different ways to do this. Here we use the C2D command and update the plant model of the MPC object with the discretized plant. Now we go back to the adaptive MPC block and type in the MPC object. Next, we need to provide the controller with a plant model that is updated at each time step for the current operating condition. The pre-built update plant model block takes care of this calculation. When we double click on it, we see that it has been implemented state space matrices. It then computes the discrete model and also updates the nominal conditions with the current operating conditions. Now it's time to connect the inputs and outputs for this block. We already have all the inputs here: longitudinal velocity, the steering angle, and the states. The model input of the adaptive MPC control block requires the discrete time model and nominal conditions in the order that we've created in the MATLAB function. To connect the outputs to the controller, we select the block and create a bus signal. Now we're ready to try different longitudinal velocities and see how the controller handles the varying plant dynamics. In the previous video, the traditional MPC controller designed for an operating condition of 50 meters per second had worked well, while it failed to control the system at a different longitudinal velocity of 35 meters per second. With adaptive MPC, we get good controller performance when longitudinal velocity is 50 meters per second. If we now change it to 35 meters per second, we still get good tracking of lateral position and the yaw angle. We can even